Yes. I haven't done anything yet. Come on. All right. Yeah, that's my name, Dennis Doomen. I'm from the Netherlands. That's I have this strong accent. Event sourcing. Who actually knows about event sourcing already? Ooh, like half of the people. Who's still coding? Less than half of the people. So the rest is architects or managers or something like that. Okay. So in 2009, I actually ran into event sourcing the first time because I got a training. Maybe you know him, Greg Young. He's kind of the inventor of event sourcing, or he kind of coined the term. Was pretty popular in the .NET space. I'm actually a .NET developer. How many .NET developers are there? I was afraid of that. The rest is Java, and the half of it doesn't code, of course. So I started building a system for a client. I'm a consultant. And we started building it using the command query responsibility segregation architecture style. It's a long name, CQRS. And then at some point we converted to event sourcing, and I knew it was going to be painful. I prepared everybody for it. I convinced the manager that it was the proper way of doing it, but it still was incredibly painful. It still hurts every day. You can see that. My back hurts and everything, but I still love it. So the goal of the next 50 minutes is to kind of show you some of the good things, some of the bad things. There's still room here in the front, there. The bad things, and maybe some of the ugly parts of it. Just to prepare yourself, like if you're actually going on this endeavor, that you know what you're at. Maybe you're experienced already, and I probably see some people saying, like, knocking their heads, like, yeah, I recognize that problem anyway. So, who am I? Small guy from the Netherlands. I have a blog, Continuous Improver, where I try to talk about everything to improve myself, architecture tools, teams, everything that is part of our job. The .NET developers may know my open source library, but that's not really relevant, and my Twitter feed. Anyway, event sourcing 101. So half of the people actually know it, the other people don't. So let me introduce event sourcing. I have a web application. The web application sends a command, maybe change user email address. It will find through the command service, which is kind of a broker, a handler. The handler responsible for actually applying the business rules applicable for changing a user's email address, which will not be that excited, maybe the structure of the email address. What will happen is the email handler will actually find a unit of work to load the entire history of that user object from the event store. So the history. It doesn't actually load a record. There's no user record. No, it's going to ask the event store, like, give me everything that happened functionally on that object. It was created, a role was granted at some point, his email address or her email address or one's email address got changed, everything that ever happened. It loads that from the database. We call it a write database. So event sourcing and CQRS are two different things, but they really work well together. At that point, it will create a user object and tell the user object, load those events, reload yourself or rebuild yourself from history. Then you have something that looks more like a traditional object that is loaded from a database using an object relational mapper and invokes the method to change the email address, which, if the email address actually changed, applies an event on itself to change the state, and then the command service will tell the unit of work, you know what, now we're done, store this into the database. What will it do? It will request the user, okay, what are the changes that were applied inside this action? Store that in the write database. Well, obviously, you can't really read from a write database. That's why we call it a write database. So you need something else, because in fact, it's just a flat structure with the entire history of all the systems. So typically what you'll find is it will dispatch that event, in this case, the user email address changed event or something, to what we call a projector. The projector is responsible for storing that through some data access layer, whatever it is, into a read database. Then the web application can execute the query. And maybe it finds a query handler or something else and loads it from the database. That's a really complicated structure for just loading and data, so applying some domain changes. But this is what event sourcing is about. So the fact that the source are the events, that's where the name is coming from, hence event sourcing. Make sense? Don't ask questions because there's too many people here, but I will be available for the rest of the day. So the good. Anybody recognize this? People old enough to know who this is? Yeah, he's still alive, Clint Eastwood. but then 50 years before, even before I was born. All right, well, you can do some cool stuff with projections. You can actually create multiple projectors. So the idea is that you take the events, store them in a database in a structure that's optimized for querying. So you don't have to have a single data model both for reading and writing. You can actually have multiple read models optimized for that particular purpose. So if you have I can't say a shitload, but a lot of data and you want to store it in a database and you want to maybe group it in a certain way, sure, databases are really efficient. But if you can actually do this up front, so when the event, you know when something's changed, you got the email address. So if you want to know, show me all the email addresses which are from the .gov part, you can already count that up front and create a specific projection for that will provide the information for you on the fly. And of course, since these projectors are really dumb, you don't even need like an ORM anymore. You could use something similar like raw SQL or one of the equivalents that exist in the Java space. I don't have a lot of experience there. As I said, and since every projector is autonomous, you can even have multiple databases. Because if you really build a high-performance system, what is the bottleneck, usually? Except bad code and technical debt like the previous session. Database? Anybody? Yeah? Yeah, usually, yeah. Well, world has changed, of course. We have now NoSQL solutions and big data and everything. But this really aligns well with it. Because every projector can potentially be stored in a separate database. Great for sharding. But another thing is which you can do, you can even decide to say your events are going to be projected asynchronously. So let's say you have 25 different projectors that want to store the data in a like optimized way. They don't even have to wait for each other. You can just, scale out the whole thing, fan out all the projection because you don't actually need to wait for it from the UI perspective. Of course, that causes some consequence for the UI. You need to think about that. Or what about a projector that directly renders to HTML? Why wouldn't you do that? You can. It's supposed to be optimized for that particular part of the system, a page or something like that. Just pre-render the HTML because you know when the data is changed, you can make decisions about that. You can do some more cool stuff. Let's say this is the history of an object. We call that functional transactions, just like a real database. This is time. You could decide, and by the way, it's immutable, so an event store doesn't change at all. So you can actually say like, okay, this is SOX compliant. That's where it's really popular for it. That's where it started with it. But you can also have temporal projectors, things that create a read store, a readable representation that represent a particular point in time. Because you can go back. You can go back in time. You can go further in time, which is pretty powerful. You can even do that in memory if you want to. If the amount of data for a particular object is pretty limited, you can build this on the fly. Reporting, that's a typical question I get. Like, you know what, you have this event store, which is completely unreadable. It's a huge thing. But we have these traditional clients that like to have like a reporting model, a relational model that they can connect to their OTAP, data mining solutions. You can do that as well. Same thing here. But now you build a couple of specific projectors that build something that really resembles a reporting database. It has foreign key constraints and everything else. It's it's normalized into the third form or something like that. You can, and of course it's I don't know if you can see that, but it's a dotted line again, which means it doesn't have to run in the same transaction as the user interface is doing. It can be even offloaded. You can put a bus in between. Make sense? Yeah. All right. That's another cool thing. So suppose I have an object called Dennis. It's me. And it has version 3, or revision 3 is what we usually call it. It has a couple of events in its history. It was created, a role was granted, and a phone number was added. This is what's the persisted state. Now I'm offline, and on another machine, like physically disconnected, I apply a role. I grant myself, or somebody grants me a role, which is going to be, should be v4. But it happens in parallel. Then, on this side, the password is changed because there's some kind of Active Directory integration or something like that. Then on the other side, my password is changed as well because I was actually working on my laptop. There's a version of the product installed here. So I have changed my password in 2 different places. And my role was revoked for some reason. So we basically have things that happen to the same object. Then what? If you have like a traditional system, you probably use optimistic concurrency or something, and you get like exceptions and stuff like that, like the record has already been changed. So let's see what happens if we compare stuff. Is the row grant event, for instance, a conflict with the password changed? Is it? I see people say no. Probably not. Is that a technical discussion? Probably not either. It's a functional discussion. It's something you need your product owner for. Who always has access to his product owner in a project? Just to check. Wait, the rest of you build software without consulting your functional people? I'm afraid, yes. Well, event sourcing is one of the ways to really get them into them. Let them make the decisions, give them options. Well, I mean, the whole purpose of Scrum is that you actually have your product owner sit with the team, which never happens. Anyway, password change. Oh, sorry, the role granted versus the role revoked. Is that a conflict? Depends. If it's a different role, who cares? It's not a conflict. Is the role granted a conflict? Oh, sorry. Basically, what happens at the end, then the role granted is put on top of this store and applied as if it's a change later on. There's no conflict, you just put it on top of that. Then we have the password changed. So is this a conflict? Maybe. Could be, depends. But maybe it's perfectly fine to say if I change the password at a later point of time, and the difference in time is big enough, like usually 5 minutes is not enough because machines have different server times and they usually are within 5 minutes. But if it functionally could be, you could just say actually that it's perfectly fine, and we say, okay, the last one just wins. Is this a conflict? No. This a conflict? No. So we eventually put the password change here. This possibility to do event merging in a functional way where you compare every change with any other change is a pretty powerful technique, because traditional systems just give you an error and then you somehow have to figure it out. And in the case that one of these things, one of those particular events actually result in a functional conflict that the end user has to resolve, it's still pretty easy to do that because you have all the information. You know exactly what the intention was at that time. Make sense? Yeah? All right. One other cool thing is you can do something like replication on an application level. So this is the history. This is the event store. You see numbers here, 1, 2, 3 until something. I can't read it, but probably there you can read it. And this is the projection data. The user interface does queries and all that stuff. So if the event store is immutable, so every new event in the future has to be backwards compatible. The code base that interprets those events has to be backwards compatible. What you can do then is take another machine that basically copies over the events on the fly and projects them in whatever structure you want. So you can use it as a kind of application level replication process. In fact, this can be SQL Server. This can be Oracle. Could even be a NoSQL database. These could be 2 different versions of the product. That's perfectly fine. So you have a nice mechanism for copying over the data from one version to the other and build your projections side by side. We use that. We have a distributed system. We do distributed event sourcing. So we have a product that's deployed on an oil platform, and then onshore on the office, they prepare all kinds of permit to work documents and do risk assessments and isolation certificates. But then people are on the ship or on an oil platform, or maybe they are going underground. So we've built a system that actually replicates the data in a nice way. It's really cool. You can do some interesting stuff with that. It's not obvious, of course, to build this, otherwise I wouldn't do this talk. One other thing is anybody practicing domain-driven design? Just to check. Also a couple of people. I really wonder what the rest of people are doing here, but okay. So let's say you have like a domain like this. It's called an aggregate root and has a couple of entities and has a value objects. These are terms from DDD. Don't worry if you don't remember that. By the way, the slides are already on the slide share, so you can look everything up. But this stuff is just the code that represents, that gives the events a structure that you can look at from runtime perspective at runtime. So what you can do, you can actually redesign, take the events, and build a completely new structure here, which is perfectly fine. Whose system actually change over time? Like if you look, really? Yeah. Requirements change? How often? Every week? Every day? You know, in the morning and in the afternoon, the user stories change again. That's pretty common. You will not be able to design, at least I'm not, and maybe there's some smart people here, You can't really design a system up front and expect it to stay like that. Business rules change. You get breakthroughs. It's a pretty common thing in domain-driven design. So being able to change the structure of your domain, redesign the invariants that apply there is really powerful. You can do that. You just take the old events and replay them in a different structure. Perfectly fine. We can do that. Which brings me to the bad, in addition to all the broken pixels in the screen. Yeah. By the way, the movie is called The Good, the Bad, the Ugly. It's a traditional, like, old-style Italian spaghetti western. And the people with gray hair recognize it, of course. The young people like, what is he talking about? Is that the new Marvel movie? No. So there's, of course, it has some good things, but there's also some things that are less trivial. Wrongly designed aggregate is one example. Yeah? Who has designed his aggregates first time right? Almost got you. Right. Yes. No. Usually they're wrong. But that's not a bad thing. I mean, good software doesn't exist. Evolving software does. One of the things you do that I did wrong, or we did wrong, is designing a domain based on ownership. So you have an order, and the order refers to products, and there's probably a user or client, and we basically look at things like, okay, an order contains order lines, and each order line refers to a product, so we design our entities around that. That's wrong in DDD. It's really common to do it like that, but it's really wrong. I'll show you what you have to do after this. Relying on eventually consistent projectors is also a thing. So what will happen if you start to use event sourcing is that at some point you'll have to get data. You have a command handler that has to do some complicated things. The information is not actually in the domain, it's not in your aggregate, so you need to query some projection. If you decided to go all the way async and made all your projections asynchronous, or even if they are synchronous, they're never true. So if your command handler gets information from a projection table and makes decisions based on that, you need to be aware that that projection table is not completely up to date. Because at the same time, somebody may have executed, like added a new order. And if there's, for instance, a maximum for that order, if you didn't design your aggregates according to that, you will not be able to rely on that. It's an easy thing to trip on. Functional keys. Yeah, we had something. We designed a user, and we thought, hey, you know what? Usernames, they're unique. Every username is unique, which makes sense. So the functional key of an entity in an event store is really important. It's the thing that you use to find all the events in history for that particular object. So it needs to be pretty stable. Well, we also thought was stable until we actually had to work with Active Directory, and we discovered that it's possible for a username to change. That doesn't work. So now we use GUIDs. And we created our own deterministic GUID mechanism that would take a string, like a username, create a GUID from it, all kinds of ugly stuff, and it will sprinkle all over your code base, which is called technical debt. That's something you really have to think about. Some people say always use a GUID just to be on the safe side, because your functional key may change. Maybe not in the first year, but probably in the second year, like us. Another thing is happening, okay, you know, we had these nice domain event, they get raised. Maybe we can use this domain event, you know, the username is changed as a trigger to execute some additional validations. You know, because we like to decouple stuff. So we have an aggregate that changes the user email address, and then we raise a domain event that, you know, there's a domain event handler taking care of that, and then doing all kinds of verifications, triggering exceptions. That becomes really ugly. You may wonder, why the hell we even do that? Well, people do that. And the worst thing is to put specific domain-specific types in your events. So, like an email address. You don't want to sprinkle your entire code base with the notion of what is a valid email address. So what people generally do in the DDD world, they define a value type that represents the email address, you know, verifies the rules. If you put that in your event, and then 2 years later you start to deserialize an entity from the event store using that type, but the rules have changed, what will happen, the event will actually refer to a type that has different rules, but the old value doesn't match anymore. So it might even explode in your face. Don't do that. Use primitive types only. Well, first thing is what you have to do is find the right boundaries. That's the most difficult part. So define what is an aggregate. There's a couple of things. First, you need to ask the question about consistency. And there's a nice article written by Von Vernon. It's a 3 PDF thing. I have a link at the end of the slide deck that helps you with that. You need to understand the consistency there. What business rule really needs to be enforced by this object? Like, if there's a rule that a particular client cannot have more than 10,000 euros, or what is it called, Plotsky? Can't really remember. Help me, please. I have no physical money anymore these days, but let's say a euro can't have more than 10,000 euro worth of orders. Where do you verify that? Do you add a property or some concept to the user object, or do you create some global thing? That rule, you need to think about it. If the system has to absolutely protect you from doing that, you have to make it part of your entity. There must be an entity that protects that. If it's perfectly fine to go over it and have a compensation action, then you don't have to put it in the same aggregate. This is the most difficult part, by the way, of doing domain-driven design correct, even though you may not be doing event sourcing. The other thing is understand the real world. Understand how the real world works, because as a developer, we tend to make everything transactionally consistent, right? At least I do, and all the people I work tend to do that. Try to understand, like maybe in the real world, it doesn't have to be perfect. It's perfectly acceptable to compensate at a later point. Something to remember. And then, consider the invariance and use that to decide what becomes the aggregate. Because only within the aggregate you can be consistent. And aggregates obviously have to be really small. So if it's really important to assure that you never cross or exceed the 10,000 K in euros, you'll need to define something that keeps track of all the orders for a particular user. That object itself is not an order. It's maybe an object that contains the username or something that identifies the user and the total of the orders. And whenever you create a new order to the user, you have to ask the aggregate, is that actually allowed? And you end up with a completely different domain. There's no order, there's no user. But there are things that are mixed and matched. And I'm not even going to talk about bounded context because that makes it more complicated. By the way, if you move from a pre-event sourcing architecture to a new one, you will not be able to use ORMs or anything to navigate from your order to your products and from your product to the catalog and all that stuff. You have to reference by identity. I see everybody looking at me like, these are open doors. I already knew that, obviously. All right. What else? Practical challenges. So this is, and obviously it's in C#. This is an order class. And it has a cancel method. And what you can see is actually what it does. If the status is in progress, then you can actually cancel it and it will apply an order cancelled event. Then you'll have something like a when method that will take that event and apply it to itself. You need an entry point in your code that is being applied when you execute an actual command on your aggregate, but you also need something that reinstates the state of the object when you replay it from history. That's a pattern. So this when method is called during dehydration, when the aggregate is loaded from the event store, and it changes the actual status property or field or whatever you call that in your language to cancel. But even the cancel method itself, which does the verification of the business rules, applies an event to itself. Well, if your aggregate is pretty big, it becomes ugly. So there's different ways of doing this. This is a class that contains everything in the same one. So here's the status field. You can also have, and that I don't know if that exists in Java, but in C# you can use partial classes, which basically is a trick to separate the code into multiple files, but it's still the same thing. What I've been using for a while is maybe something called an order state object. So your order has a reference to something that collects all the details of how to handle all the different events, so that your main class order only needs to care about like what are the business rules, what is the entry point, what are the rules that apply to particular things that I do on an order. Different ways. It's more like a practical thing. We use this, also don't like it really that much. If it's possible, I would probably use partial classes. Event granularity is another really complicated thing, and I don't have the ultimate answer. What is better? Saying that the risk assessment level has changed, pretty generic concept, and because of that, there was a risk assessment team member removed, and another one, because we have in this domain, we have a kind of risk assessment process, and somebody decides that for the work to be done on this oil platform, it's either level 1 or level 2. If it's a level 2, you actually have to select a team to work on that. So when the level reduces from 2 to 1, you have to remove the team because you no longer need it. Are you going to capture as like really fine-grained event like this? or you're going to capture it as risk assessment level demoted, which is more functional. The right side is more intention revealing. The left side is more clear what is expected. It's a difficult one. This one is really nice because if you have to handle the same events on lots of different projections, you don't have to remember the fact that if the level goes from 2 to 1, you have to remove the team. So you don't get duplication. I don't like duplication. Don't repeat yourself. The other one, is more intention revealing, but then you have to remember what the rules that apply there. And if you the rules change. We just concluded that. Everybody was happy with the fact that things, well, not happy, but they acknowledged the fact that rules and business rules change over time. So if the rules change and you're going to handle an old event, you may project it with the rules that apply right now, which was not the intention at that time. So we generally choose the fine-grained defense, but there's no single solution. As I said, I won't talk too much about bounded contexts, but bounded context is a way to have multiple domains which have different rules or different rules for the same concepts. They may also have an order, but different rules apply. Like the financial system also has orders, but they don't care about the people there. They may only care about the financial consequences. And the rules are different, and you may actually choose different event granularity levels, especially if you go into the microservice world. Event versioning is another one. That's the most painful one. So I have this event, and it's in a DLL called domain, and it has a namespace domain.riskassessment, and the type is risk assessment level changed. That's how you start with that. Assembly is like a package, I think, in Java, a jar or something. But then something changed. You initially started with a single project called domain because your domain was really small, but then at a later point, you said, well, no, actually, we have a separate domain for threat assessments. And we actually started to define namespaces based on like risk assessment.risks. And maybe even an event changed because we changed our mind. We went from fine-grained defense to coarse-grained defense. Then you have to create code that takes the old events and converts them to the new one. Otherwise, your code base has to handle every past version of the event. That's painful. This is something you have to think about. And this will happen. We have events that have like the V5 extension to it because there were 5 incarnations of the same event over time. Painful, but true. And if you have a lot of them, at some point you might even decide to create some kind of reconciliation process that takes with this replication that I talked about, takes the old event store, processes all the events and only keeps the last one, just to keep the size, in check, and to move all the, because if you deserialize a V1, you still need to have code that understands V1, and V2, and V3, and V4, and you need to make sure that everybody's actually using V5. Problems that you will run into. The ugly. Projection rebuilding pains. So imagine your system runs for a couple of years. You have millions of events. You have like 200 different projections, all optimized for that purpose. So when you go from one version to the other and schemas change, you have to rebuild all that. You have to rebuild millions of events. That can take hours, I would say. It could even take days. Then what? And this is a real common, everybody who has real experience with event sourcing should recognize that. I'm looking for people like, yeah, I recognize that. Yeah. Who is actually doing it right now, event sourcing? That explains a lot, yes, okay. You all run into projections that crash. So everything fine, all your unit tests, because we're all practicing test-driven development. Yes, yeah, okay. Half of the people is not coding, so I'm not really sure what they do. But so everything is successful, your unit tests all succeed, all your builds are green, and then you start to take a production database and upgrade the product, and then things fall apart. Because, I don't know, maybe the column size changes. Maybe the rules that apply to a particular projection column changed, and you didn't even know about V1 of that event anymore, that at that time it had a particular value, or that particular field was not nillable at that time, like null versus non-null. So the new developer looks at the event and like, okay, clearly, if you change the email address, you need to have a valid email. Obviously, that's of course the simplest example. But there might be maybe there was a date field at that time, or maybe the previous email is actually now part of the event, but it may have not been there before. And at least in C# and I suppose in Java it's the same thing. is just a string. And you don't actually see from the event whether it's nullable or not. Can you see that in Java? Anybody can? No, you can't see that. Same thing. So you look at the event, and unless there's some nice documentation on that event, and everybody, of course, documents all their code properly, it will not say anything, and people will just assume it's valid. It's always there. And create a nice projection, which has the old email address in a non-nullable column. And then you start, rebuilding your new schema based on that existing production database, and then boom. And if it's asynchronous, it happens somewhere in the background. And you get production reports. You'll be called in the weekend, in the night, or when you're at the conference. Can happen. Or maybe there's some dependency between projections. Somebody created a nice lookup because they want to have the time zone for a particular area in a nice lookup. And that time zone lookup was actually pretty slow at some point, and somebody rebuilt it, or they reused it because developers are really good at reusing. Oh, there's already a lookup. I'll just use that one. Yeah, and then you discover in production that there's actually some timing differences between the two. You run into that one. So your projections have to be autonomous. Maybe you're doing a partial replay. Also happens. You change the structure. Or the event store got restored because there was a database backup was being restored. And then your code is still like, oh, I have new events. I'm going to update my projections. But the projections were actually ahead of time. So they contain changes related to events that are no longer in the event store. If you then receive new events, and it tries to update records in that projection table, it explodes. I see people look, really? Why is event sourcing so cool if you have so many problems? Maybe there's bugs. Maybe. I don't know. Who writes bug-free software? Again. If you don't write any code, you're not going to introduce any bugs. That's clearly true. Yeah. Well, we had something like, we have this projection that has a couple of child records associated with it. But then somebody decided, that was already perfectly fine, and then somebody decided to make their projections asynchronous and run them on multiple application servers in parallel, which is also perfectly fine. The only problem is if both of the machines are trying to update the same projection at the same time, you actually run into problems. And if there's no unique constraint on your child records, because people don't know database anymore, they treat it as a storage with stuff and that's it, you might actually end up with child records that are duplicated. We've had that. And you don't really notice it until it runs in production. A unit test all succeed again. Probably your dry run will also be fine until the load really increases and lots of people are using a system in parallel, updating records and aggregates, emitting events that have to be projected. Then things like that happen. Or large event stream. We had that one. So we had Active Directory import process that would import information about users, like fields like the telephone number. And that process runs every couple of minutes. So that import process will take the record from Active Directory, try to find the corresponding user from the event store, and try to update the phone number. But what somebody forgot to do is to check if the phone number actually changed. And if it doesn't, if it actually didn't change, but you still apply an event, after a year you have 1 million events just for that user, which nobody notices because nobody looks at the event store. But then somebody tries to modify that user object in a user management page, and they say, you know what? It takes me a minute just to load that user object. What's going on? Now you can imagine that I just told you that if the user object is dehydrated, it loads the entire history of that object from memory, tries to update it all the time, and then the actual command can be executed. If there's 1 million email addresses, the only thing they do is update the email address to the same value. That's not really efficient. Fixing that is really hard because, as I said, an event store is immutable. People are used to the fact that nothing really changes, you just add more events to it. Now suddenly you have to do something really crappy. You have to delete objects from that store. That is surely going to cause some explosions here and there. Hopefully not really, but caching strategies also happen, like a lookup. Again, that lookup that will give you the time zone for a particular platform, there might be a caching error there. You've had that as well, because people thought, yeah, that information is really local. I can just use an Amaru cache or something like that. But if it's wrong, especially in load balance environments, and they use a different truth, then your projections get corrupt. Try to find that out. Probably a user will complain, like, you know what, I just created the permit for this platform, but somehow the beginning and the end dates are not correct. It didn't start on time, and try to trace that back to a projection that was using the wrong time zone, and then trying to figure out, okay, but how did it actually get to that time zone? These are really difficult problems to analyze. Identity case sensitivity is another thing. So if your permit for, or if your user, if we use the username as the identity of a user, is the username like Dennis with capital D and Dennis with lowercase d, is that the same thing or same person? Probably. Depends, but it's a functional question. Probably. So what we did, as I said, we had a problem because username changed. So what we did, we calculated a deterministic GUID from the username to be able to in the future handle, generate new GUIDs for new users. But a username, like a string, which has a capital D or a small d, actually ends up in a different GUID in a different identity. So you'll find different objects. So from the event store's perspective, these are two different streams, two different aggregates. Dennis with a capital D and then you start to project that. And anybody using SQL Server? Yeah, okay. Everybody Oracle? Ooh, the rest not using databases. I really start to wonder what you guys do. I'm going to ask later on. Okay, SQL Server is case insensitive by default. So if you try to create a record with the name Dennis, a capital D, and Dennis with a lower d, it will probably just update the same record, even though from an event store perspective, it's the same thing. Sorry, they are different things. Yeah, these are like bugs that will cost you a lot of time trying to find them back. And if you read from an event store and you do that asynchronously, you might actually run into problems that transactions are not complete and you have gaps in your event store. It's a pretty complicated thing. It's an edge case that we run into. If you're in a .NET space and you would use an event store or Greg Young's own event store, you might actually run into some pretty interesting problems. But if there's a lot of concurrent inserts, it's possible that you read a page of events from your event store, but since there's an ongoing transaction, you have a gap. And if you track the last commit so that you know where to continue after that, you may never catch up. It's an edge case. I have a link at the end. You don't have to remember that right now. But it can completely kill your entire system and basically cause the business to lose trust in you. So what can you do to reduce the rebuild time, especially for large event stores? You can do side-by-side rebuilding. As I said, this replication process, you can also use it to take the event store, take the events which are mutable, build a new structure side-by-side in a new version, and even have like an automatic blue-green deployment. You can use archivability. So at some point, if your permits are closed, you can decide to mark all your streams or all the things in your event store as archivable, and then use that for it at some point to offload the data to a slower event store. You can copy the data, create separate projections for that, for the old data. You could even say like, and you need projection tracking for that, because if everything becomes asynchronous, if you start the application, the active data might still be there, but if somebody goes to a search screen and says, give me all the closed permits, they're not there. They may still be rebuilding in the background because everything is asynchronous. So you need to build an eventual consistent UI, which is also really difficult. You need to tell users, you know what? You're not looking at the most recent data. And depending on the particular screen, that may not be a problem. That is something you need to decide on case-by-case basis. You may even simulate a consistent projection by continuously polling the projection in the background, or just assume that because the command was executed correctly, all the business rules were valid and processed, you just update your view state or your HTML in JavaScript using React to simulate the fact that everything was fine, even though the projection is not up to date. There's nice tricks for that. There's a lot of publications by that on the internet. But for instance, if you now have a differentiation between documents that are active and documents that are closed and archivability are archivable, you could even build projectors that first try to project the active data so that it is immediately available after the upgrade or as quickly as possible, and then do the rest in the background. But that means that your projections have to be autonomous. And autonomous means asynchronous. So to really build this right, you have to build them asynchronous, which requires eventual consistent UIs. I made the mistake of not doing that because I didn't want the complexity. We decided to make everything synchronous because that looks really close. As I said, we converted from a CQRS to event sourcing architecture, from a relational database to this. The entire UI was based on the fact that everything is synchronous, consistent, but that has caused so much problems like this. And partitioning. If you have a functional partitioning key, you can actually build multiple event stores side by side so that the user interface actually knows to what database to go. Or make distinctions like this partition is much more important for the operations of the system and make decisions about that. And that's the beauty of this whole event sourcing architecture. You can make decisions, functional decisions about what is more important, how to deal with conflicts, what information is more important than the other ones, but still get the scalability benefits. You may even want to have dynamic rebuilding, and we have, especially if there's a production bug. As I said, like the column didn't fit anymore. The title of a permit was supposed to be 200 characters, or 255, which is the default, and then somebody wanted to make it bigger. Why? I don't know. The PO, the product owner, wanted to change it, and you forget to update your projection. Of course, you can ship a new version, and then do this again, this replication out-of-place upgrade process, but maybe somebody just ships a SQL script, and you want to go to a special page and say, rebuild this projection for me. That's something you can do. Maybe it's automatic. Maybe if there's a new version of your code, of your projector code, you can calculate a hash from the actual code, from the compiled version. And if the hash of that particular projection has changed, something has been to rebuild, and it will build itself automatically in the background. Some pretty advanced stuff you can do there with the metadata of your underlying runtime, like the CLR in .NET and the JVM in Java. So some tips and tricks. There's a couple of solutions. If you're in the .NET space, which nobody is, there's a library for that, so I'll skip that. Not really important. An event store and get event store also in the .NET space. I have heard that Kafka is trying to solve a lot of these problems. I myself am not really eager in using a framework for building my systems. My experience after 20 years is that if you use a framework, they tend to somehow, become weed in your code base. And if you want to get rid of it, you can't, because it's really, everything is tightly coupled to your framework. Especially if you want to change things, you have to figure out, how do I override this default behavior in my framework? So I have honestly no experience with Kafka. There may be people in the room, I love to hear that after the talk, if anybody has tried something like that. But I like to build my systems in small pieces. That's why I have another talk at 2:30 about building libraries instead of frameworks. In short, event sourcing is really cool. It is. You can actually build really high-performance systems. The scalability is enormous. It's really incredible. Being able to build like HTML pages from your events, so you never even do need to create a database, that's really awesome. And you have lots of options. But lots of options means lots of choices, lots of decisions. There's lots of things you have to think about. There's lots of bugs that can happen. So I don't want to demotivate anybody from trying to apply this pattern, but it's just an architectural style. It's something you put in your back pocket, like everything you hear on conferences, that if you run into a particular business case, you might want to use it. And if you do domain-driven design, it's not a top-level architecture. It's something that happens on a smaller scale. Within a bounded context, you can use event sourcing, and maybe other parts of the system don't need this. So be careful with that. Don't apply it like a lot of developers do, dogmatically, just like design patterns. They're just ways of communicating about it. So I hope I gave you some kind of a high-level overview. My blog, The Continuous Improver, has a whole series about this, because everything I talked about, I've really extensively blogged about that to share all this knowledge. Yeah, I actually am done. 5 minutes left. If you have any questions, you can do that now or approach me later on. I thank you for your attention and for the big group here. Enjoy the conference the rest of the day.